Hi, Seth here, and welcome to the channel. These 4 images were generated in a batch. Using the first image as a reference, I can get consistency with the overall style. I did this without using ControlNet or any adapters. Take another example. Style is consistent across multiple references. The pose, facial expressions, background, hairstyle, and lighting are consistent with the reference. And with ControlNet, I can get better control. You can also use multiple ControlNets with style aligned. Let me show you the workflows and hacks in ComfyUI. I want to thank all the channel members who continue to support the channel. The style-aligned image generation via shared attention was developed by Google. A big shout out to Brian Fitzgerald and Jason Phillips from GitHub. They are responsible for bringing this custom node to ComfyUI. Style-aligned is quite different from IP adapter. It generates a series of images with a consistent style, while IP adapter incorporates and interprets visual information from an image in image generation tasks. Style-aligned is potent and consistent because it employs shared attention mechanisms within the diffusion process to achieve style consistency in image generation. ControlNet is not required for style-aligned to function. However, I will show you how to use ControlNet with style-aligned for better control. Comfy Manager must be installed, and some know-how on ControlNet functions is required. Go to the Comfy Manager and install the ControlNet auxiliary preprocessors and the WAS node suite. Python GAUS is also required. I will use the batch prompt schedule from Fizz nodes. The seed node from RG3 is used in all workflows. Lastly, install the style-aligned nodes. After installation, close the command prompt in the browser windows. Open a new window and go to this GitHub page. The link is in the description. Click on the initialization.python link and download the raw file. Copy and paste the raw file into this folder. This is required because the code has not yet been merged into the master branch on GitHub as of the date of recording this video. The style-aligned reference nodes are still a work in progress. The first workflow is quite basic. Add the VAE loader for the checkpoint. For the positive prompt, add the batch prompt scheduler. This node will allow you to send multiple prompts in batches in one flow. A normal clip text encode for the negative. Add the style-aligned batch align node. This node is specific for generating images with the same style in batches. The reference image workflow is a bit later in the tutorial. A custom node for the seed is very helpful here. Add the RG3 seed node. Add an empty latent node and 2 K-samplers. I am adding 2 for comparison. One of the K-samplers will connect with the style-aligned. The checkpoint model connects with the style-aligned input, which further connects to one of the K-samplers. Connect the clip and the VAE. Right-click on each of the K-samplers and convert the seed to input. Then, connect the sampler with the custom seed node. The second K-sampler directly with the checkpoint model. Positive and negative conditioning. And the empty latent. For the entire tutorial, I will stick to the RealVis XL version 3 checkpoint with the baked VAE. This checkpoint works very well with all the workflows. The turbo models will not work correctly on all resolutions. To minimize errors and inconsistency, I suggest you first try the workflow with this specific checkpoint before your preferred one. If you are not getting the desired results even with random seeds, the problem probably lies with the setting. Check the guidance and steps value recommended for the checkpoint. For this specific workflow, I am using steps at 15 and guidance at 5 with DPM++2M SDE Keras. Make sure both the K-samplers have the same settings for comparison. This is where you enter dynamic text in the prompt. For example, let's say white cow. The number on the left is the frame when the prompt changes. For the workflow, it will be in increments of 1. So the first prompt will be 0, the second will be number 1, and so on. The maximum frames value should equal the lines entered in the dynamic prompt. Since I have a single line, the value should be 1. Whatever you enter here comes before the dynamic keywords entered above. Let's say a cute plushie toy. Anything you want after the dynamic text should be inputted here. Example, furry on the moon, depth of field, space, cartoon, and open mouth. If I show you the command prompt, you can see it compiles the prompt into a single line. When you add more dynamic text, everything else will remain the same, and it will generate multiple prompts and schedule them one by one. Let's add another line, say, brown horse. Change the value to 2, and the batch size as well. The style align takes the first image in the batch and uses it as a reference. The plushie cow, in this instance. You will be surprised that it copies more than what we usually term as style. Look at the way the horse is positioned. It accurately reproduced the cow's posture and changed the standing horse to a sitting one. Also, notice the similarities in the background. It also manages to change the toy's expression. Another fascinating thing is that it copies the lighting and the shadows as well. In image generation using neural networks, the difference between group and layer normalization lies in how they adjust the data. Keep this value at both. So far, I have not seen any difference between selecting group or layer. QKV stands for queries, keys, and values. Imagine you're at a large party with many guests and trying to find people who share your interests, let's say, skydiving. Queries is you asking around trying to find people interested in skydiving. Keys are like name tags that every guest in the party wears. Some guest would have their interest on a name tag. Values represent the story or info that each guest has about skydiving. So you, the query, look for guests, the keys, who share your interest, and once you find them, you exchange stories and tips, also known as values. Similarly, in neural networks, queries seek out relevant keys, and based on this, the corresponding values are used to perform the model's task, processing images, in this case. Typically, for batch prompting, Q plus K is recommended. QKV is overkill. I do use that option further in the tutorial. Here, the scale value is recommended at 1. Reducing the scale value reduces the consistency of the first image, thus affecting all the images in the batch. As you can see, most of the details are lost. Let's check out how reliable and consistent style aligned is. I am adding a total of 8 animals with different colors. Beautiful. Every one of them is consistent. I want to try changing the shark to a blue jay. And it works beautifully. Changing the prompt to try a flat logo illustration with a shadow. The best way to go about this process is to pick a subject and keep doing the generation till you are satisfied with the style you want. Once you choose a style, fix the seed and add more dynamics. It can be limiting if you want a huge batch of the same style. One way to overcome it is to create a batch supported by your GPU and then create another batch, keeping the first image the same. And keep repeating until you get all your desired subjects. Without style aligned, the design and shadows of the logos are completely different. And with style aligned, you have the perfect consistency. I have tested the batch style aligned extensively, and it works. Another thing is that the subjects do not have to be related. For example, adding a lion and a tree also works. So, without changing the conditioning, I am changing the checkpoint, and this one cannot do anything correctly except the burger and the pizza. With style aligned, it makes a huge difference. Notice how it replicated the blue hue behind the burger. For the first image, focus on the style rather than the subject and then start the process. The reason to use ControlNet is to control the reference image. Beyond that reference image, Style Align does a better job in control than ControlNet itself. I will use the OpenPose XL model. Right-click and add the Upscale Image node and the OpenPose preprocessor. I will use the reference pose from this image. Connect the positive conditioning through the ControlNet. Negative conditioning for ControlNet is not required. The Upscale Image node is required here to resize the input. Use the crop option if needed. Ensure that the resolution of the image matches the ControlNet and latent image. Any discrepancies in the resolution will give an error. I am alternating between a male and a female subject. Also, the hair of the first subject is curly, whereas the third and the fourth subjects wear different clothing styles. Take note of the two males. Even with ControlNet, the images not style aligned do not have the exact same pose. Whereas with style aligned it is identical. Not only that, it even changes the face of the male to be exactly like the reference. It does not change the hairstyle because of the prompt. If I removed the hairstyle from the first prompt, they would be the same. The red color is a bit dark. This is because the reference image shirt is blue. By changing the color in the prompt, it tries to color over the blue instead of a new generation. Lighter colors fade towards blue. I am sure there is a way to overcome this issue, but I need to do further testing. In this workflow, I will first generate an image, which will be the target image. Then, I will load up a reference image and try to influence the target style as per the reference while preserving key features of the original generation. Pass the reference image via a VAE encoder. This step is crucial for style aligned. It ensures that the generated images match the textual description and consistently reflect the style of the reference image. Now add the sample reference latent node. Drag and connect the sampler input with a K-Sampler select node. Add the basic scheduler for the Sigma. We will need a separate conditioning for the reference latent. The negative conditioning will be the same, however, the positive will differ. When you want to randomize generations, change the seed from the latent, not the sampler. This will ensure that the target image remains the same. Also, keep the guidance scale here between 3 and 4. I did not get good results beyond this range. Instead of a K-Sampler, the reference sampler node gets added, which further connects to the VAE decode. The positive from the target gets connected to the positive input of the reference sampler. And the positive reference conditioning connects with the reference positive input. The negative conditioning is the same for both. The prompt here is significant and sensitive. The prompt should be a close approximation of the reference image. To make things easier, I will add the blip analyzer nodes for the image analyses. Via the text-to-condition node, you can connect the blip analyzer to reference positive inputs. When using a reference image, keep the scale value at 0.85. As per the released paper, that is the default. Okay, this is probably because I forgot to resize. Remember to stick to near SD-XL resolution only, and don't go too tall or too wide. The ability of style align to maintain facial consistency is incredible. This reference image is a bit of a stretch due to the sideways pose. However, it manages to do reasonably fine. I tried some random seeds, and quite some had distortions around the neck or the back, but that's expected. Also, note that I purposely generated the target as just a close-up face without a body to test its performance against several reference images. Adding ControlNet to the workflow is straightforward. The reference positive conditioning connects with the reference ControlNet, which goes in the reference latent and sampler nodes. At the same time, the target positive conditioning connects with the target ControlNet, which goes to the reference sampler node. For the reference image, I am using Kenny, and for the target, I am using depth map. Both the ControlNet values are at 0.5. That's a good value to start with. Let's generate the target image first. Since conditioning plays a key role here, let's look at the blip and see the analysis. You don't want to put this conditioning in the latent. In this case, I would prefer to have it say just a colorful mask. Copy and paste that manually. Whenever the results are underwhelming, change the share attention to Q plus K plus V. There you go, it worked. Here are some additional tips. When using ControlNet with the reference images, Euler Ancestral with the scheduler normal gives far better results than Keras. I also used double the steps usually required for this checkpoint. I increased the guidance scale from a 5 to a 7. All these help with the desired outcome. In this example, I am taking a sports car as a target generation, and the reference image is of a dragon made out of blue and gold threads. This is quite extreme but manageable. Ultimately, I changed the target's positive prompt to say an orange sports car made of gold and blue threads. This helps Style Align focus its attention where I want it to. However, the checkpoint alone could not generate a proper car made of threads. Even after Style Aligned, the car's shape was a little loose. So, I just increased the ControlNet value of the car to 0.7, which did the trick. Also, I used Kenny for both ControlNets here. I hope you learned something new and the tutorial was helpful. Until next time.